In the vast cosmos, a drama of unimaginable scale unfolded. This is the story of Earth, our home, a tiny jewel in the grand cosmic tapestry. Our journey begins long before our sun ignited, before our planet coalesced from stardust. From the Big Bang, our universe sprang forth, expanding, cooling, and transforming. Imagine a cloud of cosmic debris, the remnants of a supernova adrift in space. At the heart of this swirling cloud, gravity drew in material, creating a dense, spinning disk. At the center, a star was being born, our sun. Further out, the seeds of planets began to sprout. Out of this chaotic dance, our Earth emerged, a molten ball of rock, still bombarded by remnants of the early solar system. The early Earth was a hostile world, shrouded in a thick, toxic atmosphere. As the Earth cooled, molten rock solidified, forming the first continents. Water vapor condensed, creating the first oceans. Deep within these oceans, at hydrothermal vents, the first life forms emerged. Over eons, these early life forms evolved, eventually giving rise to photosynthesis, transforming the planet. Eons passed. Continents drifted, collided, and ripped apart, shaping the planet's surface. Life, initially confined to the oceans, began to diversify at an astonishing rate. Strange creatures swam in the primordial seas. Giant invertebrates ruled the depths. The Ediacaran biota, the first complex organisms, flourished for millions of years. But their reign was not to last. New challenges arose, demanding new adaptations. The stage was set for a revolution, a biological explosion that would alter the course of life. Before this new era, Earth faced its most severe test yet, a global glaciation. This was Snowball Earth, a time when ice sheets stretched from pole to pole. Life teetered on the brink of extinction, but it found a way. The rise of oxygen was a pivotal moment in Earth's history. Produced by photosynthetic cyanobacteria, oxygen transformed the planet's chemistry. For many organisms, oxygen was toxic. Others thrived in the oxygen-rich environment. Oxygen allowed for more efficient respiration, enabling the evolution of larger, more complex organisms. New ecosystems emerged, driven by the flow of energy from the sun to photosynthetic organisms. But first, the planet endured a trial by ice, plunging into a deep freeze. The continents, clustered near the equator, disrupted warm ocean currents, casting a cosmic chill over the planet. Imagine a world encased in ice. Glaciers covered the continents, grinding towards the equator. The oceans, frozen over except for a few pockets of slushy water, were silent and still. Life, as it often does, found a way. In the depths of the oceans, tiny organisms clung to existence. The freeze, though devastating, may have driven rapid evolution, favouring organisms with novel adaptations. This period of intense selection paved the way for the Cambrian explosion. After Snowball Earth, the planet began to thaw. Melting glaciers released nutrients into the oceans, fueling a biological bonanza. The Cambrian explosion had begun. Life diversified at an unprecedented rate. Strange creatures filled the oceans. Trilobites scuttled across the seafloor. Anomalocaris hunted its prey. The Cambrian explosion was a time of experimentation, with evolution trying out every conceivable body plan. Most early experiments failed, but a few survived, giving rise to the ancestors of all major animal groups. On land, the first plants began to colonize the barren continents, transforming the terrestrial environment. The colonization of land was a pivotal moment in the history of life. The first animals to venture onto land were invertebrates, followed by the ancestors of vertebrates. The transition from water to land required adaptations, lungs, limbs, and new sensory systems. The evolution of plants and animals on land was intertwined, shaping the terrestrial biosphere. This symbiotic relationship continues to shape life on Earth today. Life had conquered the land, but the oceans remained abundant. This was the Devonian period, a time when fish ruled the waves. Evolution experimented with every conceivable form, from jawless fish to lobe-finned fish. The oceans, however, were not without dangers, driving evolution and creating opportunities for new species. While fish flourished in the oceans, the continents transformed. The first forests emerged, dominated by giant club mosses, horsetails, and ferns. The evolution of forests regulated the Earth's temperature, creating a stable environment for life. Insects thrived in this new world, transforming terrestrial ecosystems. Life had been confined to water and land, but now a new frontier beckoned: the air. The first animals to evolve true flight were insects, their wings marvels of biological engineering. Flight opened up new possibilities, allowing insects to escape predators, find food, and disperse. The evolution of flight required a streamlined body, powerful muscles, and keen balance. Life on Earth had weathered many storms, but nothing could prepare it for the Permian-Triassic extinction event. The exact cause is debated, but the consequences were catastrophic. Over 90% of all marine species and 70% of terrestrial vertebrate species disappeared. The Great Dying was a time of unimaginable loss, a stark reminder of the fragility of life. Yet, from the ashes, a new world emerged, dominated by reptiles, the ancestors of the dinosaurs. The Permian-Triassic extinction event had wiped the slate clean. The ecosystems of the early Triassic period were vastly different from those that had preceded them. Gone were the giant insects, the towering ferns, and the bizarre marine creatures that had ruled the Permian seas. In their place, a new group of animals emerged: the reptiles. Reptiles, with their scaly skin, water-conserving kidneys, and ability to lay amniotic eggs on land, were well suited to the harsh conditions of the early Triassic. They quickly diversified, filling the ecological niches left vacant by the extinction event. Some, like the dicynodonts, were herbivores, their beaked skulls adapted for grazing on the tough vegetation that had sprung up in the wake of the extinction. Others, like the cynodonts, were carnivores, their sharp teeth and powerful jaws allowing them to prey on the newly evolving herbivores. The rise of the reptiles marked the beginning of a new era in Earth's history, the Mesozoic era, the age of reptiles. Over the next 180 million years, reptiles would evolve into an astonishing array of forms, from the mighty dinosaurs to the flying pterosaurs to the marine ichthyosaurs and plesiosaurs. The stage was set for the reign of the dinosaurs, a period of unparalleled dominance in the history of life on Earth. The Triassic period drew to a close. Life, tenacious and ever-evolving, had rebounded from the brink. Yet, the planet was still a far cry from the lush, vibrant world it would become. The continents, locked in the supercontinent Pangaea, baked under an intense sun. Volcanoes rumbled, spewing forth gases that choked the atmosphere. But from this crucible, a new dynasty was about to emerge. The dinosaurs, descendants of the resilient reptiles that had weathered the Permian extinction, were initially small and inconspicuous. They scurried amongst the undergrowth, overshadowed by their larger, more primitive reptilian cousins. But within these unassuming creatures lay the potential for greatness. They possessed a unique set of adaptations that would allow them to thrive in this changing world. Their legs, positioned directly beneath their bodies, provided them with greater agility and speed compared to the sprawling gait of their reptilian predecessors. This revolutionary stance, a hallmark of the dinosaur lineage, allowed them to cover ground more efficiently, whether chasing prey or escaping predators. It was a subtle advantage, yet in the crucible of survival, even the smallest edge could tip the scales of destiny. Furthermore, the dinosaurs possessed a remarkable respiratory system, more efficient than that of any other reptile group. This allowed them to extract oxygen from the air with greater efficiency, fueling their active lifestyles. As the Triassic world grew hotter and drier, this adaptation would prove to be a crucial asset. The Jurassic period dawned. Pangaea, the supercontinent, began to rift and split, creating new coastlines and altering ocean currents. This tectonic upheaval, coupled with a surge in volcanic activity, released massive amounts of greenhouse gases into the atmosphere, driving global temperatures upwards. The world was entering a period of intense heat and humidity, and the dinosaurs were ready to inherit the Earth. With astonishing speed, dinosaurs diversified and spread across the globe. Some, like the colossal sauropods, Brachiosaurus, Apatosaurus, Diplodocus, grew to unimaginable sizes, their long necks reaching heights no other land animal has ever matched. These gentle giants, their massive bulk supported by pillar-like legs, roamed the continents, their appetites as immense as their stature. But the Jurassic wasn't just a parade of titans. Smaller, more agile dinosaurs, like the swift-footed ornithomimids and the armored stegosaurs, evolved alongside their colossal kin. The skies, too, became a stage for the dinosaurs' dominion. Pterosaurs, close relatives of the dinosaurs, soared through the air, their leathery wings carrying them on currents high above the heads of their earthbound cousins. The oceans, teeming with life, saw the rise of marine reptiles. The dolphin-like ichthyosaurs, the long-necked plesiosaurs, and the fearsome pliosaurs. These aquatic predators patrolled the depths, their streamlined bodies slicing through the water with deadly grace. The dinosaurs, it seemed, had conquered every corner of the globe. As the Jurassic gave way to the Cretaceous, a profound evolutionary shift was taking place. Within the dinosaur lineage, a new branch was emerging, one that would forever change our understanding of these magnificent creatures. These were the feathered dinosaurs, the ancestors of birds. Fossils from this period reveal a stunning array of feathered dinosaurs, some small and bird-like, others larger and more reptilian in appearance. These feathers, initially simple filaments, likely served as insulation, helping these dinosaurs regulate their body temperature. But over time, feathers evolved into more complex structures, taking on new functions such as display and, most importantly, flight. The origin of flight in dinosaurs is a tale of gradual adaptation and remarkable evolutionary ingenuity. From simple gliding leaps to powered flight, these feathered pioneers pushed the boundaries of what was possible, their wings taking on new forms and configurations with each passing generation. The skies, once the exclusive domain of pterosaurs, were about to welcome a new dynasty of aerial masters. This feathered revolution, however, wasn't just about conquering the air. It was a testament to the incredible adaptability and evolutionary potential of the dinosaurs. From the massive sauropods to the tiny feathered theropods, dinosaurs had demonstrated an unparalleled ability to thrive in a wide range of environments and to evolve into a breathtaking diversity of forms. Section 4. The World in Bloom. The Cretaceous period was a time of incredible biological abundance. The continents, now separated by vast oceans, were adorned with lush forests, teeming with life. Flowering plants, or angiosperms, made their debut, their vibrant colours and sweet scents transforming the landscape. This botanical revolution would forever alter the relationship between plants and animals. Insects, those masters of adaptation, flourished in this new world of floral abundance. Bees, butterflies, and moths evolved alongside the flowering plants, their lives intertwined in a delicate dance of pollination and co-evolution. This partnership, still thriving today, is a testament to the interconnectedness of life and the power of symbiosis. The oceans, too, were a riot of life. Giant marine reptiles still patrolled the depths, but they were joined by a new cast of characters. Ammonites, with their spiral shells, thrived in vast numbers. Bony fish, more agile and adaptable than their cartilaginous counterparts, diversified rapidly, filling the seas with their shimmering schools. The Cretaceous was a time when life on Earth reached a pinnacle of diversity and abundance. The dinosaurs, at the height of their reign, dominated the planet, their presence felt from the depths of the oceans to the highest peaks. Section 5. Cataclysm from the cosmos. For millions of years, the dinosaurs had ruled supreme. From the depths of space, a harbinger of doom hurtled towards Earth. The impact, when it came, was unimaginable. The asteroid, estimated to be 6 miles wide, slammed into the Yucatan Peninsula. The shockwaves triggered earthquakes, tsunamis, and volcanic eruptions. The skies darkened as debris engulfed the planet. The age of dinosaurs was over, and a new chapter in Earth's history was about to begin. In the shadow of giants. The reign of the dinosaurs was over. Their world lay in ruins. The skies were choked with ash and debris. Forests were reduced to smouldering wastelands. Yet, life would rise again. A new struggle for survival began. The dinosaurs were gone. Small mammals were poised to inherit the Earth. Their time to rise had come. Mammals had lived inconspicuously. They scurried through the undergrowth. Their size and habits allowed survival. Their true potential was unleashed. The impact winter-devastated ecosystems. Dinosaurs were vulnerable to upheaval. Mammals were better equipped to weather the storm. As the skies cleared and the sun's warmth returned to the Earth, the survivors of the asteroid impact began to rebuild their shattered world. Among them, the mammals seized their opportunity. With their former reptilian overlords gone, mammals adapted and diversified, mirroring the resurgence of life on a recovering planet. Mammals, with their remarkable adaptability, filled vacant ecological niches, from dense forests to open plains, from frigid poles to scorching deserts. Mammals radiated outwards, driven by natural selection. Their resilience and adaptability proved to be the keys to their success. Within the grand tapestry of mammalian evolution, primates embarked on a unique trajectory. Agile climbers with grasping hands and binocular vision, they thrived in the trees. Their story, a testament to adaptation, ultimately led to us. The Paleocene and Eocene forests were a haven for primates. Amidst the canopy, they found food, shelter, and opportunity. Their versatile hands allowed them to manipulate objects with unmatched dexterity. Their eyesight transformed, enhancing depth perception. Binocular vision was crucial for navigating the trees. The cooling climate and spread of grasslands presented new challenges. Some remained in forests, driven by arboreal life. Others ventured onto the savanna, adapting to new environments. These pioneers faced challenges, evolving larger bodies and complex social structures. Millions of years passed. Continents drifted, shaping climates and evolution. In Africa, the cradle of humankind, a new chapter began. From primates, beings emerged, destined to walk upright and reshape the planet. The transition to early hominids was pivotal. Our ancestors adapted to ground life. Bipedalism freed hands for tools and exploration. Fossils show our journey to Homo sapiens. Early hominids adapted to their environments. They shared intelligence and innovation. Stone tools marked a turning point. Tools allowed new food sources and defense. Fire and language changed human-nature relations. From our humble origins as a small, unassuming primate in the heart of Africa, we, Homo sapiens, have risen to become the dominant species on Earth. Our journey, however, has not been without its consequences. We have polluted the air and water and driven countless species to the brink of extinction. The future of Earth, and indeed our own fate, hangs in the balance. Are we masters of our own destiny, or merely passengers on a runaway train? The choice is ours, and the time to act is now. We stand at a precipice. Behind us, the long and winding road of Earth's history, marked by both triumph and tragedy. Before us, a future shrouded in uncertainty, a tapestry of possibilities yet to be woven. The choices we make today as a species will determine the fate of our planet and the legacy we leave behind. The challenges we face are daunting. Climate change, driven by our relentless consumption of fossil fuels, threatens to disrupt the delicate balance of Earth's systems, unleashing rising sea levels, extreme weather events, and mass extinctions. Resource depletion, fueled by our insatiable appetite for energy and materials, strains the planet's ability to provide for its burgeoning human population. Yet, amidst these challenges, there is hope. We possess the ingenuity, the technology, and the collective will to chart a new course, to forge a future where humanity thrives in harmony with nature, not at its expense. The key to this sustainable future lies in embracing a new paradigm, one that recognizes the interconnectedness of all things, the delicate web of life that sustains us. We must transition from a model of exploitation to one of stewardship, from a mindset of short-term gain to one of long-term vision. Technology, often portrayed as the antagonist in the story of our environmental woes, can also be a powerful force for good. Just as our ingenuity brought us to the brink, so too can it help us step back from the precipice. The future holds the promise of technological marvels that can help us heal the planet, conserve its resources, and create a more equitable and sustainable world. Renewable energy technologies such as solar, wind, and geothermal offer the potential to power our civilizations without the harmful emissions that drive climate change. Advances in energy storage and smart grids can make these clean energy sources more reliable and efficient, freeing us from our dependence on fossil fuels. Precision agriculture, guided by sensors, data analytics, and artificial intelligence, can help us produce more food on less land, minimizing our impact on ecosystems while ensuring food security for a growing population. Vertical farming, with its stacked layers of crops bathed in artificial light, offers the promise of growing food in urban environments, reducing transportation costs and bringing fresh produce to areas where it is needed most. Biomimicry, the art of emulating nature's designs, can inspire a new generation of sustainable technologies. From buildings that mimic the ventilation systems of termite mounds, to high-speed trains modelled after the aerodynamic beaks of kingfishers, the natural world offers a wealth of untapped potential for innovation. Our future is not confined to Earth. We look to the stars, driven by a primal urge to explore the unknown. Space exploration is rapidly becoming a reality. Private companies are developing reusable rockets and space tourism ventures. Government agencies are planning ambitious missions to Mars and beyond. These endeavours hold the potential to unlock new discoveries and inspire future generations. The colonization of other planets could provide humanity with a backup plan. It could also offer us new perspectives on our place in the cosmos, fostering a sense of unity and shared responsibility for our future. From the fiery chaos of the Big Bang to the emergence of life on a fledgling planet, we've journeyed across billions of years. We've witnessed the rise and fall of empires, the blossoming of countless species, and the enduring power of life to adapt and evolve. And we've come to a profound realization: Earth, our home, is but a pale blue dot in the vast cosmic ocean. Imagine, if you will, the sheer improbability of it all. The countless cosmic coincidences, the delicate interplay of physical laws that led to the formation of our solar system, our planet, and ultimately to us. It's a humbling thought, one that fills us with a sense of wonder and awe. We are, each and every one of us, the product of billions of years of cosmic evolution, our very existence a testament to the enduring power of life. The iron in our blood, forged in the hearts of long-dead stars, the oxygen we breathe, a gift from the first photosynthetic organisms, the very atoms that make up our bodies, recycled countless times through the grand cycles of the cosmos. We are, quite literally, stardust. And yet, despite our profound connection to the universe, we often forget our place within it. We build walls, draw lines in the sand, and wage wars over ideology, resources, and power. We lose sight of the bigger picture, the fragile beauty of our planet. the interconnectedness of all life. But it's not too late. We have the power to change our course, to write a new chapter in Earth's epic saga. A chapter marked not by conflict and destruction, but by cooperation, innovation, and a deep respect for the natural world that sustains us. The future is not predetermined. It's a canvas upon which we, as a species, can paint our hopes and dreams. We can choose to embrace a future where clean energy powers our cities, where sustainable practices guide our actions, and where technology serves to enhance, not exploit, the natural world. We can choose to break down the walls that divide us, to bridge the gaps between cultures and ideologies, and to work together to address the global challenges we face. For in the grand scheme of things, we are all interconnected, our fates intertwined on this pale blue dot we call home. Our story, the story of Earth and its inhabitants, is still being written. The challenges we face are real, but so too is our capacity for innovation, compassion, and resilience. Let us move forward with a renewed sense of purpose, a shared commitment to safeguarding our planet's future, and a deep appreciation for the extraordinary journey that led us to this moment. For the story of Earth, our story, is far from over. As we reflect on the incredible journey that has brought us to this moment, we stand at the threshold of a new era. The choices we make today will shape the world of tomorrow, not just for us, but for countless generations to come. Thank you for watching. If you enjoyed this journey through time, please like, share, and subscribe for more fascinating content only at the Cosmos Facts channel.